Friends, the question is, during the change of O2 to O2 minus, the incoming electron goes to the orbital. This question is based upon the molecular orbital theory, and according to MOT, for the molecule like O2 and N2, the preference of the orbitals are sigma 1s, sigma 1 asterisk s, sigma 2s, sigma 2 asterisk s, sigma 2pz, pi 2px, pi 2py, pi 2 asterisk px, and pi 2 asterisk py, and so on. Asterisk denotes anti-bonding orbital. Now, since we know that total number of electron in O2 is 16 and O2 minus is 17. So filling the orbital according to the Hund's rule, Aufbau rule, and Pauli's exclusive principle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1, 15, and 16 according to the Hund's rule. Now, since the total number of electron for O2 molecule is O2 minus is 17, so filling it again for O2 minus. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and again filling it by the Hund's rule in 17. So the incoming electron goes to pi 2 asterisk px. So the correct option is option 3. Thank you.
Hello students, question says that HF has highest boiling point among hydrogen halides, okay, because it has option 1 strongest van der Waals interaction, option 2 lowest ionic character, option 3 strongest hydrogen bonding, and option 4 lowest dissociation enthalpy, okay. What we have among hydrogen halides, what we have halides are HF, HCl, HBr, Hi. Okay, we know that if we have stronger force of attraction, stronger intermolecular force of attraction, higher will be the force of attraction, higher we have to boil the temperature. Okay, higher will be the boiling point. So the boiling point is proportional to forces of attraction, force of interaction or force of attraction. Okay, so we can see here that in HF, in all in there are four hydrogen halides. In HF, except HF, all three hydrogen halides has no hydrogen bonding, but in HF there is, due to polarity, due to more electronegativity of fluorine, there is hydrogen bonding. So partial negative charge on fluorine and partial positive charge on hydrogen. So the hydrogen bonding will takes place. Okay, hydrogen bonding in HF will takes place. and we can see that it has zigzag structure. It has HF has zigzag structure. Okay, this HF and this HF. Okay, this is HF. So this is partial positive and fluorine has partial negative. Okay, because of more electronegative. So this is the hydrogen bond, which this bond is, this is zigzag like structure, and this is hydrogen bond. Okay, there is hydrogen bonding, and in HCl, HBr, HI there is no hydrogen bonding. Their boiling point will be based on, they will consider on the basis of van der Waals force of attraction. So higher is the molecular mass, higher will be the van der Waals force of attraction. Okay, but here hydrogen bonding is more forces of attraction as compared to van der Waals force or London dispersion force. So as we can say, HF has highest boiling point. Okay, why HF has highest boiling point? Because of hydrogen bonding. Because of H bonding, HF has highest boiling point among hydrogen halides, Okay, so what will be the answer? So the final answer for the question is option C, strongest hydrogen bonding. Option 3, strongest hydrogen bonding. Thank you.
Hello students, so if I talk about this question, among the following species the diamagnetic molecule is, okay, we have options here. Option 1 NO, option 2 O2, option 3 is CO, and option 4 is B2. Okay, so let's find out which is diamagnetic molecule. Okay, so first of all I will talk about what is diamagnetic. Okay, so the diamagnetic substance is said to be that substance which have a paired electron, right? There is absence of unpaired electrons, right? Okay, these are those which have paired electrons, right? Okay, so let's see one by one in these substances which have paired and unpaired electron. Okay, so first of all I will talk about here first option, that is NO. Okay, so in this NO we know nitrogen have 7 electrons and oxygen have 8 electrons, right? Okay, so total electrons are in the NO is 15 electrons, right? Okay, so according to MOT, molecular orbital theory, right? This is molecular according to the molecular orbital theory. Okay, if electrons are greater than 14, then bonding should be look like this. Here we have sigma 1s star, sigma 2s star, and anti-bonding orbitals, right? Star represent anti-bonding orbitals. Okay, so the filling of electrons in these orbitals should be look like this. In this orbital 2 electrons, in this 2, okay, sigma 2s 2, in this 2, okay, Z, which is more stable than 2px and 2py. Okay, so in this 2 and 2, here in pi 2p there is 2, and in pi star 2px there is 1 electron will fill. Okay, so we have here all paired electron, but we have one unpaired electron, right? This is one unpaired electron in this So it means this NO compound is paramagnetic in nature, right? If there is one or more unpaired electron present in the orbital, then it's said to be paramagnetic in nature, right? Paramagnetic in nature. So this is not a diamagnetic molecule. Alright. Okay. Now we will see the case of option 2, that is O2. Okay. Here if I talk about second, that is O2. O2 has 16 electron, right? 16 electron. It means electrons which is greater than 14. So according to the molecular orbital theory, the filling of electrons should be look like this. Here we have sigma 1s, sigma 1s star. So the filling of the 16 electron in this orbital should be look like this. 2 electrons, 2, 4, 6, 8, 10, okay, 10, 12 and 14. Okay, and as we pi star 2px and pi star 2py, they have equal energy, so one electron will fill in this. Okay, so as you can see, there is all electrons are paired, right? All electrons are paired, but these 2 electrons are unpaired here, right? 2 electrons are unpaired. It means this O2 molecule is also paramagnetic in nature. Okay, paramagnetic in nature. Alright, now we will talk about the third option, that is a CO molecule. Okay, so for CO, here CO carbon has 6 electrons and oxygen have 8 electrons. Okay, so the total electrons are 14 electrons, and according to molecular orbital theory, the filling of electron in the orbital should be look like this. Here the electrons are 14 electrons, right? Less than 14 electrons. So the orbital should be look like this. Here now we will fill these 14 electron in this orbital. 2, 4, 6, 8, 10. Okay, 10, 12, 12 and 14, as one electron will go into these orbital. Okay, and after they will pair up with equal energy. Okay, so as you can see, the here all electrons are paired, right? All electrons are paired. It means here there is no unpaired electron. This means this compound, CO compound, is diamagnetic in nature. Okay, now we will talk about our last compound, that is B2. Okay, so for B2, here B2, for B2 there is 10 electrons. Okay, so we will fill this electron in the molecular orbital, right? Here sigma 1s, pi 2py, right? Here electrons are greater than 14 electrons, right? Okay, so the filling of electrons should be look like this. 2 electrons, 2, 4, 6, here 8, and one electron will go in this orbital. Okay, so as you can see, there is 2 unpaired electron, right? There is 2 unpaired electron, so this compound is paramagnetic, not diamagnetic. Okay, paramagnetic in nature. Alright, Okay, so this is paramagnetic in nature. So according to the molecular orbital theory, O2, NO and B2 are paramagnetic according to the MOT, and CO is diamagnetic. Okay, so the correct answer is option 3, that is CO is diamagnetic. Okay, thank you.